2A. All right, so we're still in our prerequisites chapter, so this is all review. We're going to talk about functions. Functions. All right, we've got two parts today. The first part, we're going to refresh or remember domain and range. Some of you hate this, huh?
All real numbers.
All real numbers every time.
That's what I guess.
False. Okay, first of all, we need to recall what a function actually is, okay? Because there's two things. You can have a relation, and a relation doesn't necessarily need to be a function. It can be. It's just a set of ordered pairs. Set of ordered pairs. So a relation can be a circle, because that's ordered pairs that make a circle. When you plot every single point, it makes a circle. But we know that's not a function. Because of what? Yes, the VLT. Sounds delicious. Because of the VLT, vertical line test, can't hit more than one time. Now that means that we kind of know what a function is. So what is a function? Well, a function assigns a unique y for every x. A function assigns a unique y for every x. So have you ever seen like a function machine like this, and it has like and it spits something out over here, and then x goes in as your input, y comes out as your output, okay? So for any x that you plug in, a new y will come out, kind of thing, okay? Like if you plug in 5 and you get 25, right. But if you plug in -5, you still get 25. But if you plug 5 back in, it's not going to spit out 36, right? It's not going to give you two numbers for that 1 5. Okay? So we're good. All right, so that's a function. You know, I was going to go through all this again, but I think you guys know. There's like basic ways to show a function by mapping, by a t-chart, by points. You guys know all this, and I don't want to insult you. All right, let's go ahead and do domain and range. So domain are going to be all of the x values of a function. X values, okay? These are the independent values. Like, for example, if I was going to make a t-chart, I can choose whatever I want to for x. Those are my independent numbers. But when I plug them in, they're going to be, the y's will depend on whatever the x's are. So the range are the y values, which are dependent. Now, if I ask you to find the range of something, I will let you use your calculator, okay? If I ask you to find the domain, see, domain's more important than range. If I ask you to find the domain, sometimes we don't let you use your calculator. All right? So let's do some. Are you ready? Yes. Yeah, you are. Number 1. We're going to find the domain. We're just going to do domain, and then we'll open it up to the range, and we'll get our calculator out and do it that way. All right, so we're going to find the domain, some of these functions. Here we go. F of x equals 2x over x squared minus 9. All right, so the domain are all the x values that you're allowed to have, but it's better to find the x values that you're not allowed to have, right? You got it?
Yes.
What can x not be?
3 or -3.
Perfect. 3 or -3. So the domain of this would be all real numbers. That's what it looks like. It's a capital R, and it looks weird. Except for plus or minus 3. Okay? And that's a perfectly fine answer. In interval notation, which sometimes I think the book does, yeah.
Wouldn't it just be x is not equal to 1?
Yeah, you could probably x. Yeah, put an x there. Oh, that looks like a prescription. RX. What was I going to say? Maybe not. Oh, interval notation. Sometimes your book will use interval notation, so they'll go negative infinity to 3, but not including 3, union, or negative 3 in this case, union negative 3 to 3, union 3 to infinity. No. Okay? This symbol, this parenthesis means not included. So this entire thing that I just wrote out really just means all real numbers except for negative 3 and positive 3. But it's gross, right? Do you like writing it that way?
No.
Me neither. All right, letter B. How about f of x equals the square root of x minus 7. We're just finding the domain, not the range yet. So find the domain of that guy. Oh, you got it already?
Oh, yes.
Yes? What is it?
It can't be 7 or less.
Okay.
Or 6 point.
See, okay. Hold on.
Can you have 0 in a?
Yes, you're allowed to take the square root of 0. So
it's going to be not including 7.
it does include 7 though. So x minus 7, the stuff on the inside, all this stuff in here, has to be greater than or equal to 0. You're allowed to have 0. So you would add 7 over to the other side, so the domain would be x has to be greater than or equal to 7.
Oh, you do that for all of them?
Yeah. Yeah, even this one right here, like if you talk about fractions, you know that the only restriction is that x squared minus 9 cannot be 0. You're not allowed to divide by 0. So you could actually set that equal and solve. So you would add 9 over, take the plus and minus square root. So that's another way, like just to solve them out like that. It's a really good way to do them. So for that one. And then if you wanted to write this in interval notation, 7 is included all the way out to infinity. That's how it looks like. Okay, what else? Let's do some ranges now. Number 2. Find. Is it? Number 2. Find the range. We'll do a couple of these. Let's find the range of f of x equals, let's do something fun. The square root of x plus 3. Range is harder, right? The domain of that's easy. Everything has to be greater than or equal to 0 is the domain. What's the range? Well, let's graph it. All right, so if you have your calculators, you can, or I'll just graph it for us. The square root of x plus 3. Yes, and some of you can do this without a calculator, which is great. What this is this is just the graph. It's the radical graph being shifted up 3. Do you remember what the parent function for the radical graph is? The mother function? It looks like that. And then you shift it up 3. And so that would be the graph. Okay? So then the range of this starts at 3. So you would say y is greater than or equal to 3. It goes above it. Okay? You can kind of look at it too. Like you know that this right here, what's the smallest that rad x is going to be? 0. And then if you add 3 to it, that's the smallest y can be, would be 3. Everything else above it. All right, let's do another one. All right, let's do f of x equals 2x plus 1 over x minus 3. Let's find out what the range of that is. Do you remember graphing those last year?
No. Nope.
Yes, they were so fun. No. Remember, they had branches. No?
Cannot equal 3, for sure.
So, okay, so that's the domain. The domain would be all real numbers except for 3. And then the range would be, okay, so I'm going to go to my calculator, put parentheses around it, 2x plus 1 divided by parentheses x minus 3. Now, you used to graph these by hand in Ham and Ram, but we don't. We can graph it on our calculator, and that's what it looks like. Yeah. Okay, so it looks like this. There's a branch up here, and there's a branch, and there's some asymptotes going on. So we know that there's an asymptote at x equals 3, right? So we know that the domain is not 3. But there's also an asymptote going this way. And there's a couple ways to figure that out, okay? Guessing's not a good way. If you hit trace, and you follow this out to the left, bless you, or to the right, you're looking at the y value. Okay, 1.6, 1.7. What is it approaching? 2. 2. Yeah, I'll do 2.5. So this would be all real numbers, except y is not going to be 2. Now the other way to see that is this. I don't know if you remember this. If you look over here, 2x over x, their degrees are the same, and so there's an asymptote at y equals 2. No? You don't remember that?
That's legal?
That's totally legal in all 50 states. I think so.
That it?
All right, that's it. Do you feel pretty good about domain and range? All right, part B now. Shout out to my brother Kevin if he's listening. How's New York, brother? All right, part B. We're going to do eon.
Oh, I thought that was like a lesson.
What, 11 minutes? No. Eon. All right, what is eon?
Elon Musk?
Even,
Odd.
odd, neither. All right, even, odd, neither. So let's take a look at this. Even functions. Even functions have some interesting things about them. F of negative x is going to be the same thing as f of x. Okay? Even functions are symmetric over the y-axis. If they're symmetric over the x-axis, they're not a function, right? Symmetric over the y-axis. So think about your most basic even function. Simple old parent parabola, right? Y equals x squared, or f of x equals x squared. So here's your parabola, f of x equals x squared. And you know that when you plug in 3, you get 9. And when you plug in the opposite of 3, you get 9 still. Okay, that's what this means, right? Up here, f of negative x equals f of x. They're equal to each other. Okay, so that's an even function. Now, an odd function is going to be symmetric over what? Nope.
Rotate 180.
Yeah, it's over the origin. The origin.
Yeah.
So he wasn't in RAM.
Rotate 180.
So f of negative x will equal the opposite. When you plug in the number and you plug in its opposite, they're going to be opposite of each other. And this is symmetric over the origin, which is kind of weird. Okay? Symmetric over the origin. So if you think about your very most basic odd function, just like f of x equals x cubed. Now, not all quadratics and all cubics are odd or even, okay? These are just... You eating in here? No, you're not. No, do you? No, it's not snack time. Nope, snack time's between classes. Definitely not in this one, for sure.
Can I finish it?
All right, but don't ever do it again. All right, here we go. Here's your, this is ugly, really ugly. I don't like it at all. Here, see what you started? Do you see this?
I've got a whole bag of these gone before she noticed.
Wow. All right. Oh, that's what you wrote, I think. That you had the best time, like,
Yeah.
eating in class and not getting caught.
Uh-huh.
All right. So here we go. That's an odd function. It's symmetric across the origin. If we were to pick a point on here, say x equals 3, you plug it in, what do you get? 27. It's a cubic function.
Oh, wow.
3 cubed. And then if I plug in x equals negative 3, what do I get? Negative 27. Okay? So it's symmetric across the origin. Right there. All right, so here we go. Let's do a hard one. What are we on? Number 3. No. This is all algebra 2. This is all
Wait, what
basic.
about a neither function?
Oh, a neither won't be symmetric either over either one of those. So like, here, I'll give you an example of a neither. F of x equals x cubed plus 2. So this is the cubic function shifted up 2, like that. So it's not symmetric over the origin, and it's not symmetric over the y-axis. Okay, so let's try one now. Let's do f of x equals x times the square root of x plus 2. Now, no idea what that is. If you want to, you can try to plug in the positive number and the negative number, or you can just graph it. So we'll go x times x plus 2. It's a neither, isn't it? It's kind of an interesting graph, though. No? It's kind of fun. Yeah, this one's neither. It's kind of boring. Yeah, it kind of does, huh? So this one was over here at -2, and it dipped down. It went through 0, and it looked like that. Yeah, but it doesn't go up. So that was a neither. It's kind of boring. Let's try number 4, another one. Let's do something fun. How about f of x equals the square root of x squared plus 4. Let's try that one. See what that one looks like. They'll be weird. They'll be things that you're not used to doing, you know? We never graphed that before. Maybe you have in your freelance time. All summer long, instead of golfing, right, Hayden? Kevin golfs. He's pretty good. My brother Kevin. Shout out to Kevin again.
I just golfed.
Oh, that Kevin. No.
Kevin is in here.
He is. There you go. Is that even, odd, neither? What do you got? Even. Even. Even Steven.